All right, let's take a look at another CodeWars exercise. This one's called High Score Table, and it's making the kind of thing you'd see in an old arcade game where it might display the top 10 scores of Pac-Man or the top 10 scores of Frogger. When we start at empty, the first one is definitely in there no matter what. And when we have a few more, we still have room. But then it gets interesting when it's full. So if there are 10 scores and I get somewhere in the middle, then we have to put me in the middle, shift the other ones down, and kick out the guy who would be 11th. So this involves sorting, limiting the size, and all that stuff. But the reason I'm using it is because this is making a class, making an object, and that fits with our project that we're doing in our class. The other meaning of the word class. We're making a snowflake simulation where the snowflakes move and fall and accelerate. And in order to do that, we want to just practice what is it like if you make a class and give it some attributes and methods. So for this, let's take a look. They've got an init with double underscores. Sometimes that's called a dunder method. And in Python, those are the magic methods that get called automatically. You don't have to say the name. In this case, init is called not when it's created, but just an instant after it's created, where you can fill in any initial values. Then there's an update, which is a very common name of a method. It's not a magic method. You actually say the name, but update is so common that you'll see it pretty much everywhere. And in our game, it's going to happen every frame because this is a real-time motion thing. In high score table, what they're asking for is to update it with a new value. So I say, hey, I've got a guy who just scored 13 million points. Put that in there wherever it is and fix everything to match. And then there's a method called reset, which is just to clear and start from scratch. So it sounds like the reset and the init are going to be pretty similar. We might even share some code between them. Why not do that one first? Because it's going to be so easy. So they tell us, okay, we've got a thing called scores. That is not one of these methods. That's a list. And they tell us that right here by saying it equals an empty list. So, hey, I'm just going to copy that, I guess. Inside the class, it's not going to say a name of an object. It's going to say self.scores. Well, I think it was more trouble than it's worth copying because I had to change a few things. But self.scores is going to start out as an empty list, and it's also going to be reset to an empty list sometimes. If this involved a bunch of steps, I might put it in here and then just call the reset, and I still might do that now. We'll see how it goes. When the init is called, it's specifically for an object. It's not for the class in general. So it's going to take the self parameter implicitly to say, oh, I mean this one. Not any other high score table that's out there. I mean this one. It's holding on to its own list that might be different. If I have one for Pac-Man and one for Space Invaders, they're totally separate. And what else happens when we initialize? Well, we get some kind of value. So there's some kind of parameter in here. And what is it? It is the limit. Okay, it's the limit of how many we're going to keep track of. If I'm keeping track of 3, then it's only the top 3. And when somebody is 4th, or when they get bumped down to 4th, I'm forgetting about them. Okay, so we could call that size, we could call it limit. I'm going to call it limit, I think. And then in here, I'm going to say self.limit equals limit, if I could type. Now, sometimes you want to keep that private. You want to say, hey, nobody else knows about that, and I'm just going to use it internally, and people will throw an underscore on the name. It's not a big deal in this case, but if we had a more complicated class, that's the kind of thing people might do. And does that need to go in the reset? No, because it doesn't change. If I have a limit of 3, and then later I clear it out because I'm going to start over, well, the limit is still 3. I don't have to ask again. Obviously, the interesting part is the update. We're going to take a minute to think about that. But first, I'm going to hit test. I'm just going to see what happens. Does this have any errors? Does this pass any tests? I think it's going to fail a few. Okay, it passed one, which is to say, hey, if I ask for a table of 3, does it start out with an empty list? The answer is yes. Great, so at least our init is working. We don't have any errors, obvious errors. There might be some subtle ones that show up later. But we do have some error right here, which is, hey, we tried to update it, but it wasn't prepared for what we gave it. So we need a self, which we always need a self if it's a what we call an instance method. It's happening for this one, not all of them. And then when we update it, we're giving it a new score, right? So I could call it score because it's obviously what we're getting, but it might be a little bit visually cluttered to have a score and a scores. If you see those two right next to each other, you might get mixed up. Now, I'm going to keep it score. We'll see what happens. And then the reset is also going to take a self because it's resetting this one. When I have these snowflakes in my simulation and each one is keeping track of its own position, its own velocity, it's just itself. It's not changing the rules of the class, and the class doesn't have any methods on its own, abstract level. So we're just dealing with instances, and we're having self in there. In other languages, it might be the word this, like in JavaScript, they say this, but it's the same idea. So let's hit test again. I know it's not going to pass them all, but I like to see if there are errors. I like to see if we've got the general setup. Now in this case, we passed the one that says, are we starting empty? And we failed all the ones that try to do the content, try to do the sorting stuff. But we passed the one at the end, which I assume would be resetting. Yeah. So when we reset, we do in fact go back to an empty list. So what happens when we get the new guy? Okay, I'm going to have, in theory, a handful of scores, and I'm going to add a new one and say, hey, put this where it goes. If it's the best, it's the new number 1. If it's in the middle, it's in the middle. Or if it sucks and it doesn't qualify at all, then it doesn't go in the new list. That means sometimes our update method will do nothing. If it was like 1,000,000 points, 1,000,000 minus 1, and 1,000,000 minus 2, and then somebody shows up to our game and gets 5 points, we tell them, hey, here's the top score, and you're not in it. It's the same as it was 5 minutes ago. So honestly, we could go through the algorithm of figure out which one we're slightly worse than and put ourselves after that and shift them all over. And that might be nice if we had a huge list to deal with, but it looks like they're always going to be pretty small. So we can just add it onto the end and tell Python to sort the list. Okay, sort is going to be finding the spot for it, and it's probably going to be faster since it was already mostly sorted, except for this new one. And then we can just chop it off at the end if there are too many. So what I'm going to do is I'm going to say self.scores equals sorted self.scores plus the new one. So I'm going to say add the new one and then sort. And I have to put the new one in brackets because when you're doing plus on a list, it has to be a new list, blah, blah, blah. You get the idea. And then I want to chop off the slice of however many, which is limit. Okay. Let's try that. I know it's probably not perfect, but I always like to hit test and see what happens. Would somebody get the door, please? Okay, hey, look at that. We passed one more. We failed the rest, but as you can see, we're pretty close, right? They are sorted. They're just sorted backwards. We need to put the big boys first instead of last. So the sorted function has a reverse parameter, so we could say reverse equals true. And hey, look at that. We've got it. That was just the baby test. If I hit attempt, I'll take more tests and sometimes reveal new problems. Nope, we got it. So that's great. What I like to do on these is check these solutions from other people and see if they thought of something I didn't. Every once in a while, I pass the test, but not in spirit. Like I realize that I should have failed because I forgot to account for something, and I see that other people did, or I see that other people did it in a way that might be faster or just kind of nicer. So let's see what we got here. This one is exactly the same as ours, except they had an append step before the sorting, and I think that's exactly the same if you use plus on a list. I think it just calls the append method anyway, but it might be nicer to separate them out so that a reader will see, hey, we're appending and then we're sorting. They called it limit, and they put double underscores, which I think is a bad idea because you're supposed to use those for built-in parts of the language and not your own names, but in this case it's fine. This person is using heap queue, which is a very efficient method for keeping lists of things that are supposed to be ordered, and sometimes you need to do that with huge amounts. For Python lists, we love Python lists because they're very easy to use. You can throw anything in there in any order of any type, but they're not super fast, they're not super memory efficient. And if you had in mind that, hey, what if I were doing 1 million every second, then maybe I'd want a different structure for that. Looks pretty good. It looks like we're going to see the same stuff that we typed, but let's scroll down a little bit more just in case somebody else tried a new method. This one is using the reverse slice instead of the reverse equals true, which I think this is worse. I think this is a little bit slower because you're sorting it and then flipping them all individually instead of sorting it right in the first place. But again, it's not a big deal on these small lists. This one has like a double branch thing. If we're under the limit, it doesn't matter. We just don't worry about cutting off. If we're close to the limit, then okay. Or actually what they're doing is if we're not on the list, then who cares? It doesn't matter. And if they are on the list, then okay, fine, we gotta take a look at it. Yeah, we're not gonna see any crazy stuff unless we scroll to the real depths of the underworld. But that's fun. I think it's a good exercise to get the idea of an object that updates itself, because that's what we're doing in our project, and that's what we'll do in a lot of projects in the future.